Good morning. So just before midterm, we started to look at how to find the equations of parallel and perpendicular lines. And I didn't give you any practice in it, and I did say that I was going to go over this again with a few more examples. So let's do an example today, and after that I want you to do some practice. And we'll go through the solutions of the practice questions then, and I'll be speaking with you on Wednesday. And this Wednesday, I would like it if everyone could please attend what's normally our optional session. I'll write that into Google Classroom as well. So let's start with an example. So the first thing the example says is that we have the equation of a line T. So T is the line y equals 4x plus 7. And we're going to have some questions to go along with this. So the first thing is write down the slope of t. The second thing we want to do is write down the slope of any line parallel to t. And for part 3, write down the slope of any line perpendicular to t. Perpendicular to t. Some follow-on questions. This is getting a bit long, lots of writing. Hence, find the equation of the lines M and N, just names for the lines. So let's call them P and Q. The lines P and Q, which are parallel and perpendicular to T respectively, and which go through the point 1, 7. Okay, so a bit of a long question. It's fairly easy to work with this. Now, the reason I went for P and Q and not M and N is that our formula uses M for slope. That's not to say you can't get a line called M, but I try and avoid it in examples. So P and Q. The word here respectively means each in turn. So P is going to be parallel and Q is going to be perpendicular to T. Right, let's start at the beginning. So here's the line T, y equals 4x plus 7. So y is on its own on one side, equal to everything else on the other side, meaning that this line is in the form y equals mx plus c. So straight away, what's the slope of t? It's the x coefficient here because of the pattern. So the slope of t is 4. I'm using m there. Now, the slope of any line parallel to t. So parallel lines have the same slope. So all we have to write down for any parallel line is that it will have a slope of 4 as well. And then write down the slope of any line perpendicular to t. Perpendicular, my shortcut for thinking of this is that it has the opposite slope. And what do I mean by opposite? I mean the opposite to 4, which is a quarter, and the opposite sign, so it would be negative, so minus a quarter. And then we've got 2 things to do in part 4. Hence, what does hence mean? Hence means using your previous answer. So using your previous answer. Find the equation of the lines P and Q, which are parallel and perpendicular to T respectively. So remember, respectively means each at a time. So let's start with the line P. So for the line P, we're going to use the formula y minus y1 equals m by x minus x1. So that's my formula for the equation of the line. Where does x1 and y1 come from? They come from the point. So the point 1, 7 is on my line, and that's my x1, y1. And my slope, well, P is parallel to T, so my slope is the same as T. My slope is equal to 4. I fill into this equation of the line, and I have y minus 7 equals 4 by x minus 1. Multiply out my brackets. Y minus 7 is 4x minus 1 minus 4. Gosh, I nearly forgot to multiply the 4 by the minus 1 there. Bring everything to one side. Minus 4x plus y minus 7 plus 4 equal to 0. Add like terms. Minus 4x plus y minus 3 equals 0. And finally, change the signs. Why? Because we always want our x term to be positive. So finally, my line P is 4x minus y plus 3 equal to 0. So that's my parallel line, and I've written it not in the form y equals mx plus c, but ax plus by plus c equal to 0. So everything on one side equals 0. That's the default way of writing the line if the question doesn't specify. Would I get full marks if I wrote this as y equals mx plus c? I would. I absolutely would. So I could have just said the minus 7 over here, and I would have had y equals 4x plus 3 on the other side, which you can see if we rearrange this, we'll get that same answer. Okay, let's do Q. So Q, again, I'm going to use the formula y minus y1 equals m by x minus x1. And 1, 7 is the same point, x1, y1. And m is equal to my perpendicular slope, minus a quarter. Remember that minus can go anywhere on the fraction, and I will always put it on the top. Filling in then, I get y minus 7 equals minus a quarter by x minus 1. So very similar to what I did here, except now I have minus a quarter instead of 4 here. Do you remember what we do when we've got a fraction? The bottom of the fraction, we multiply and cross by a common denominator, multiplies the y side, and the top number, the numerator, multiplies the x side. That's our shortcut. So we've got 4 bracket y minus 7 equals minus 1 bracket x minus 1. Multiply out the brackets. 4y minus 28 equals minus x plus 1. And bring everything to one side. X plus 4y minus 28 minus 1 minus 29 equals 0. You might do that in several steps, and that's fine. So there's my perpendicular line. Now, let's take a look at these. What we can see is that here the x coefficient is 4, and here the y coefficient is 4. Here the y coefficient is minus 1, and here the x coefficient is plus 1. So the x and y numbers, coefficients, have swapped, and one of the signs, the y sign, is negative on one and it's plus on the other one. Okay, so that's how we find parallel and perpendicular lines, the equations. We need to be told a point or enough information to find a point. We use the original equation to find the slope in question. And we must remember that parallel lines have the same slope and perpendicular lines, opposite slopes. Turn it upside down and change the sign. So I am going to ask you to practice with a few of these for today, and we'll do a little bit more with them tomorrow then as well. This is a bit of a hard topic, so we'll take our time with it. Okay, thank you.